We go. So this is the cardiovascular system. I'm going to probably work on. There's a movie I really want to show for this section. So I'll probably work on getting you guys a username and password for HBO Max. It is not a TVMA movie, and so I think it's quite appropriate, and it really works well for this class. So we'll talk about that probably tomorrow or either next week. But yeah, coming soon. So cardiovascular system's all about the heart and blood. We'll probably do the heart next week. We'll spend a couple days this week on blood. So let's get off. So some things about blood. It is specialized connective tissue. That's 2 free test questions from yesterday from Mackenzie. So probably a good thing you showed up today. It contains living cells, which are called formed elements, in a non-living matrix. Remember, anytime you see matrix in anatomy class, that just means the base, the thing that things are built on. So you have this non-living matrix called plasma, which carries around your living cells, which are the formed elements of your cells. If you take blood and you centrifuge it, it actually produces 3 layers. So when you centrifuge blood, what happens is all of the most dense particles end up down at the bottom. And those will be your red blood cells. Now, we talked about this before. Well, actually, I think it might be in chemistry class we talked about this, where when you give blood, if some organizations will actually allow you to give twice as much blood, and they call it giving doubles. It's an apheresis machine, I think that's what it's called. And the way it works is they hook you up to a machine, take your blood out, centrifuge your blood, and then off the top of your blood, I can't get a different color, so we have to pretend this is kind of a yellowish color. But off the top of your blood, they take your plasma off. So they take your plasma off the top, and then they re-inject it back into. And then the red blood cells and the leukocytes, the bulky coat, they keep. And you take that plasma, and then what happens is they actually do the same thing again. They repeat the process and just take the red blood cells, give you back your plasma. So they're able to take twice as many red blood cells, and you're able to walk around and be okay because your blood volume didn't change that much because they were able to give you back your plasma. So fun little thing there, and interesting tidbit. The last couple times I've given blood, though, we hadn't had that opportunity, so that kind of stuff. But other things about blood, you can get a test called the hematocrit. Hematocrit is looking at the percent of your erythrocytes. We'll talk about that in a little bit when we talk about pathology of the blood. Other things, blood is slightly basic, above 7 on the pH scale, just a little bit, 7.35 to 7.45, and it's more dense and viscous than water. Density is pretty straightforward. That's why the blood goes to the bottom of the test tube when it's centrifuged. And viscosity is a little bit different. Viscosity is a word that we need to understand that is important for blood. Any idea on what viscosity means? Anybody can answer. I only got Brand here, so feel free if you're on the Zoom. You Googling it? Yeah. Okay, so thickness. It has to do with thickness, but the technical definition for viscosity is resistant to flow. Okay, so things like maple syrup or honey, different weights of oil are viscous. They flow slower. Blood is more viscous than water. You want blood to flow slower because you don't want to get one little cut and it all pour out of your body like as if it was water. So that viscosity is important for blood to have. Makes up 8% of your total body weight is a good rough way to look at it. 5 to 6 liters in males, 4 to 5 liters in females. And that just has to do with the difference in body mass. It doesn't have anything to do with the difference in genders. It just has to do with males are usually bigger, so you have more blood. Females are usually smaller, so you have less blood. It has to also do with muscle mass as well. So what does blood do for us? Mainly, we think of blood carrying stuff around: oxygen delivery, nutrient delivery, waste removal. It is the blood mobile is the song that They Might Be Giants made. It moves things around the body. But also, blood serves to maintain our homeostasis. It keeps our pH the same. It keeps our temperature the same. It keeps our water content the same. If you start becoming dehydrated, you're going to remove water out of your plasma to replace that, which makes your blood not work so well, but it keeps you from, dying. It also serves immune system and clotting. It protects your body from disease and prevents you from bleeding out, immune system and clotting. All right, so real quick thing about plasma here. Plasma is mostly water. 10% of plasma is made up of solutes, nutrients, gases, hormones, waste, things that are dissolved in that water. And the biggest category of the solutes, 8% of the solutes, are proteins. Albumin, the carrier protein that just carries things around your body. Plasma is pretty neat little deal, but mainly for us, it's just the surface that the blood is carried upon. Most of the time, though, today we're going to spend on formed elements, and we're going to probably just talk about these guys and stop. So looking at formed elements, you have two categories: red blood cells and white blood cells. Now, that's a lot of words to write down. So anytime I talk about white blood cells and red blood cells, I use RBCs and WBCs, not the Royal Bank of Canada, but red blood cells. So erythrocytes are red blood cells. They are very small cells. They are biconcave, which means they are thicker on the edge than they are in the middle. And this is a pretty terrible drawing representing that, but it's not quite as drastic as that. But they're thicker around the edges than they are in the middle. We used to have breath mints called serfs. I don't even think they make them anymore, but they were thin in the middle and thick on the edge. It was a perfect little way to think about red blood cells. But you guys can think about them like lifesavers if the center was filled in. So if you fill in the center of the lifesavers, you'd be thin in the middle, thick on the edges, and circular. That's what biconcave is. Biconcave means that both sides are concave, both sides are going in. They lack nuclei, which is interesting because we are eukaryotic cells, which means we are eukaryotic organisms, which means our cells have nuclei. So since they lack nuclei, they also lack a lot of the structure you need to protect your DNA. Now, that does not mean that blood cells don't have DNA, because everybody knows CSI, fine blood, they got some DNA. So the reason that you don't have a nucleus in red blood cells is two things. Number one, you need to save as much space as possible. You need these guys to be small because you need to go where you're going. But also, what's the purpose of storing your DNA? To keep it safe, because you're going to need it to do what?
Tell you what to do.
Very good. You're going to need it to tell you what proteins to make, but you're also going to need it to reproduce yourself. The thing about red blood cells is they do not reproduce themselves. Like your skin cells, when we talk about the lower level of the epidermis, the stratum basal, those cells are reproducing themselves. So you need that nucleus there. Blood cells actually get produced, and we'll talk about that process here in just a second. They get produced in the bone marrow by other stem cells. And so once you make a blood cell, that blood cell is not going to reproduce itself. It's going to come from other things. It actually gets destroyed and remade in the spleen. And so you don't have to reproduce, so you don't really need that nucleus, and you can be small. 97% of red blood cells is made up of hemoglobin. Hemoglobin is this pigment. We talked about it in the last test because it gives you that red tint. Oh, there's 3 questions. And it is an oxygen binding pigment. It holds on to oxygen. Thank goodness for it, because it wants that oxygen. It'll hold carbon dioxide too, but it prefers oxygen. So it holds carbon dioxide until it gets back to the lungs. And then in the lungs, it finds oxygen, gets rid of its carbon dioxide, and takes oxygen. What chemical can be in the air that disrupts that process? What chemical are we worried about breathing in that disrupts that whole process? if you've seen the movie, not nitrogen. The nitrogen, if nitrogen just runs, we'd be screwed because most of the room is nitrogen. You seen the movie? What was the movie where they went crazy in Germany with all the people killing each other? Oh man, Midsummer came out last summer. Midsummer. At the beginning of Midsummer, there's a scene that deals with breathing in this specific gas. It's made from incomplete burning of fossil fuels. Sometimes it's the same reason you don't want to breathe car exhaust.
Is it methane?
Nope. Carbon monoxide, CO. Carbon monoxide, you breathe in carbon monoxide and your hemoglobin actually prefers carbon monoxide to oxygen. So you every molecule of carbon monoxide you breathe in, it's like destroying a red blood cell. Because that red blood cell is going to grab a hold of that carbon monoxide and then never let go of it. You just lost that red blood cell. That's why when people breathe in carbon monoxide, they just go to sleep because their body ends up with less and less energy. It's like you kind of bleed out, you get tired, you lay down, you say, God, I'm tired, you close your eyes, you never wake up. Bad stuff, but that is the function behind what's going on there. All right, the next word there is erythropoiesis. Erythropoiesis is just a fancy way to say making red blood cells. And this is important because, as I said, red blood cells do not make themselves. They come from stem cells in the bone marrow, and you're constantly making them. You're constantly making new ones. I want to say that the lifespan of red blood cell, it says short up here, but I'm pretty sure it's about a day. So if you think about 24 hours, you pretty much replace every red blood cell in your entire body. Your spleen or somewhere else destroys the old red blood cells, and your bone marrow makes new red blood cells. So we got to eat certain things so we can make red blood cells. The big three are iron, vitamin B12, and folic acid. What word goes with, actually down here, disorders? That word anemia. A lot of times people associate anemia rather than what it is, which is an deficiency of red blood cells. They say you have low iron, which is probably the most common cause of anemia. But it doesn't necessarily have to be your cause of anemia. You could have good iron and maybe have a folic acid deficiency or a vitamin B12 deficiency, or have something else that's going on in your bone cancer or something like that. But anemia is not directly an iron deficiency. Anemia is a deficiency of red blood cells, which is usually caused by an iron deficiency. The flip side of anemia is polycythemia, which is too many red blood cells. And it can be a problem like some cancers, some leukemias, some lymphomas. There's also some things called thrombocytic repro, where you start making more red blood cells than you need. But it can also be produced artificially, where people want to deliver a lot more oxygen than they should. People like cyclists and things like that, where they're going to be doing something called blood doping, where they pull their blood out and then re-inject it themselves to give themselves artificial polycythemia. Or you can even inject yourself with a hormone called erythropoietin, which is a hormone that just tells your body to undergo erythropoiesis, and it just makes a whole bunch of red blood cells, which is good because then you don't run out of oxygen when you want to breathe. Questions on red blood cells? All right, let's knock out leukocytes real quick, and then we'll call it a day. So leukocytes are another word, it's just a fancy word for white blood cells. These guys, unlike red blood cells, are complete cells. They have a nucleus, and they can be made, or they can reproduce themselves as well. Less than 1% of total blood volume, so not many of these guys compared to red blood cells. And their job is to defend us against disease. So the big 6 types of white blood cells, you have your neutrophils, which are mainly just your soldiers of your immune system. This little section right here, you can take an entire course on in college. I have a textbook over there, immunology, which is an entire course on just what we're about to talk about, but I'm going to knock it out in about 2 minutes. Neutrophils, they're your soldiers. If you have any inflammation in your body, they show up and they start checking carbohydrate markers. If you do not have a genetic carbohydrate marker that shows you belong, they will engulf you and destroy you. So they're, like I said, they're the soldiers of the immune system. Your eosinophils are important for attacking parasitic worms, things like tapeworms and hookworms and pinworms, and lots of other things that we really don't have much problem with in the first world. Why do you see more parasitic worms in Central America than you do in the United States?
They're drinking contaminated water.
Very, very good. It's you know, one of the things that we are absolutely blessed with in the United States is that we can walk over to the sink and get nice, clean, healthy drinking water, and so we don't really have to worry about our eosinophils like some parts of the world does. Next up is your basophils. Basophils are something else that we have kind of, through modern technology, moved past, and a lot of people see basophils as a problem rather than a solution now because of this guy right here, histamine. A lot of times, there's a lot of medicines out there that actually have been formulated to stop histamine from being produced. What are we talking about here? Go ahead.
Talking about how a lot of medicines are made to stop histamine.
So what am I talking about? What type of medicine? The histamine blockers. What type of medicines am I talking about?
Stuff like Claritin and Zyrtec.
Very good. We're talking about allergy meds. Allergy meds, all about blocking your histamine, blocking your production of histamine. Benadryl was the first one, but there's been a lot since then. And the reason is because how we live our life. For the first time in human history, we breathe in filtered, clean air, whereas for the first, for the last 10,000 years, humans have breathed whatever. And so our bodies are overreacting to small things like pollen and cat dander and, grass clippings. Whereas 100 years ago, our body would have said, okay, I smell that every day. Now our bodies say, oh no, we got to stop this. Inflammation, swell up, get a fever, get a hay fever, get a headache, clog everything up so that we protect the body from this. And then we take medicine to prevent that overreaction. So pretty interesting little deal there. Next one is T cells. T cells you might have heard of in a specific disease. Like what disease kills your T cells? Brandon over here just Googling like crazy. HIV. HIV is a virus that is going to destroy your T cells. Now let's look at this. T cells attack and destroy viruses. Why might that be a problem?
Because if it's destroyed, you can't stop dying.
There you go. HIV is such a freaking scary disorder because it kills the cells and attacks the cells that are going to kill it. Because it's a wild virus and it's really complicated and really dangerous because of that fact. And so it also makes it really hard to go after because a lot of the things that would slow it down also impede your T cells, which is what's going to do it anyway. So when somebody has HIV, they don't necessarily die of AIDS. They don't die of the virus. They die of a cold because they can't fight off the virus because of their loss of T cells. B cells are the guys that produce antibodies that kill bacteria. They're always making antibodies. They're always rocking it out. They're really good at helping us out with bacteria and viruses as well. And then you have your monocytes. Monocytes are, if neutrophils are your soldiers, monocytes are your tanks. These guys become macrophages. These guys are always kind of floating around. If there's a certain hormone signal, they will undergo a change, become a macrophage, and just start, wanton destruction of an area to get rid of big immune problems. Rock and roll? All right, guys. I think that's enough for today. Don't have really that big of a crowd. Mackenzie, make sure you go do your test. James, call me if you need me. Brandon, love you to death.
I have a question.
Preach it, brother.
What produces leukocytes?
Depends on which one.
Oh, right. Okay.
Yeah, like B cells are made in your bone marrow. That's why they're called B cells. T cells are made in your thymus. That's why they're called T cells. The other ones I really have to look up.
Okay.
Yep. You're the man, James. All right, guys. Have a great day. I will see y'all tomorrow.